Hazardous chemicals. They are found in more than 7 million workplaces, and over 55 million employees handle, use, or work around these potentially harmful substances throughout North America. Effects from worker exposure to hazardous chemicals can range from mild skin irritation to severe burns to the eyes or skin, to death from various types of exposure. Because of the dangers presented by hazardous chemicals, the Occupational Safety and Health Administration, OSHA, developed the Hazard Communication Standard CFR 1910.1200. OSHA's regulation requires companies to develop a hazard communication program which communicates the hazards of workplace chemicals to all employees. Your organization's hazard communication program must include a written plan. This written plan specifies the policies, procedures, and essential elements of the hazard communication program, such as container labeling, the collection, storage, and availability of safety data sheets, and a listing of all hazardous chemicals on site, as well as their location. The written plan will also detail specific guidelines for the training of employees. For example, employees will receive specific training based on the hazardous chemicals to which they may be exposed. The written plan is an important document which all employees have a right to review upon request. OSHA's Hazard Communication Standard was first enacted in 1983. However, recent changes have brought the regulation more in line with international standards. I'm referring to the implementation of the Global Harmonizing System, or GHS for short, created by the international community and adopted by the United Nations. The Global Harmonizing System provides a single set of harmonized criteria for classifying chemicals and mixtures according to their health, physical, and environmental hazards. The first component of the Global Harmonizing System we will discuss is hazard classification. Classification is the process of assigning a chemical or mixture to a hazard or danger category based on its health and physical hazards. Physical hazards are the properties of a gas, liquid, or solid that could adversely affect you or the workplace in a physical way, such as a fire or explosion. Health hazards are determined by the properties of a substance or mixture that can cause illness or injury to the skin, eyes, lungs, or other organs and body parts. Because there are such a large variety of hazardous chemicals, there are also a large variety of physical and health hazards presented by these chemicals. To better communicate the specific information needed by chemical workers, the Global Harmonizing System has created multiple classes of hazards. There are 16 classes of physical hazards and 10 classes of health hazards. The 16 classes of physical hazards include explosives, flammable gases, aerosols, oxidizing gases, gases under pressure, flammable liquids, flammable solids, and self-reactive substances and mixtures. Other physical hazard classes include pyrophoric liquids, pyrophoric solids, self-heating substances and mixtures, substances and mixtures emitting flammable gases when contacting water, oxidizing liquids, oxidizing solids, organic peroxides, and substances corrosive to metal. The 10 classes of health hazards include acute toxicity, skin corrosion and irritation, serious eye damage or eye irritation, respiratory or skin sensitization, and germ cell mutagenicity. Other health hazard classes include carcinogenicity, reproductive toxicology, specific target organ toxicity from a single exposure, specific target organ toxicity from repeated exposures, and aspiration hazard. The second component of the Global Harmonizing System, which we will discuss, is container labels. Container labels will provide information on the relevant hazard classifications of the chemical. As part of the Global Harmonizing System, chemical manufacturers and importers are required to provide a label that includes a pictogram, harmonized signal word, hazard statement, and precautionary statements for each hazard class and category. Pictograms are standardized graphics, sometimes called harmonized hazard symbols, which are assigned to a specific hazard class or category. Pictograms on a GHS label may convey health, physical, or environmental hazard information. However, keep in mind that there is not a unique pictogram for each individual hazard within each class. In other words, one pictogram may be used to represent several hazards within a class. We will now briefly explain the meaning of the pictograms you may see on a chemical label or safety data sheet. There are 5 pictograms displayed on GHS labels to represent the physical hazards of a chemical. The exploding bomb pictogram is used to signify a material as explosive, unstable explosive, organic peroxide, or a self-reactive substance or mixture. The flame pictogram is used for flammable gases, liquids, solids, and aerosols, as well as self-reactive substances. It may also indicate a material is an organic peroxide, pyrophoric liquid, or solid, a self-heating substance or mixture, or emits flammable gases when it makes contact with water. The flame over circle or oxidizer pictogram appears on a label when a chemical is an oxidizing gas, liquid, or solid. The gas cylinder pictogram is exhibited when a substance is compressed, liquefied, refrigerated liquefied, or dissolved gas. The corrosion pictogram indicates that a material is corrosive to metal. The corrosion pictogram is also used to denote the health hazards of skin corrosion and serious eye damage. Besides corrosion, there are 3 other health hazard pictograms. The skull and crossbones is used when a chemical is acutely toxic to the skin, lungs, or digestive system. The health hazard pictogram, sometimes called the chronic health hazard pictogram, denotes respiratory sensitization, germ cell mutagenicity, carcinogenicity, reproductive toxicity, or an aspiration hazard. It is also used when a substance can cause specific target organ toxicity following a single or repeated exposures. The exclamation point pictogram is used for the health hazards of acute toxicity, skin irritation, eye irritation, skin sensitization, and specific target organ toxicity following a single exposure in the form of narcotics effects or a respiratory tract infection. A third type of pictogram is used to indicate environmental hazards. This single pictogram is used when a substance poses acute or chronic hazards to the aquatic environment. Your specific chemical training, as well as your company's written plan, will include an explanation of the pictograms associated with the chemicals in your work environment. This knowledge helps workers quickly identify a chemical's hazards and is the first step to taking proper precautions to work safely. Next, let's talk about the 2 signal words that appear on GHS container labels. The words danger or warning are used to emphasize hazards and indicate the relative level of severity of the hazard. The signal word danger represents a more severe hazard than the signal word warning. Only one signal word corresponding to the class of the most severe hazard should be used on a chemical label. Other standardized communication elements found on GHS container labels are hazard statements and precautionary statements. Hazard statements are standard phrases assigned to a hazard class and category that concisely describe the nature of the hazard. For products which pose more than one risk, an appropriate hazard statement for each GHS hazard will be included on the chemical label. Chemical labels will also contain precautionary statements. Precautionary statements are standardized explanations of the measures to be taken to minimize or prevent adverse effects. There are 4 types of precautionary statements for each hazard class: prevention, response, storage, and disposal. Some examples of prevention precautionary statements include do not allow contact with water and wear protective gloves. Some examples of response precautionary statements include if on skin, wash with plenty of water, and If inhaled, remove person to fresh air. Some examples of storage precautionary statements include store in well-ventilated place and protect from sunlight. Disposal precautionary statements typically state to dispose in accordance to local regulations. Disposal precautions are an area the United Nations plans to further develop in the future. Let's now turn our attention to the other primary source of information on chemical hazards and how to protect yourself from exposures: safety data sheets. You may be familiar with material safety data sheets, or at least have heard of them. Required by OSHA's original hazard communication standard, they have been the comprehensive source of safety information about specific chemicals. Unfortunately, these valuable documents came in a wide variety of styles and formats, making them hard to read and understand quickly. As part of the globally harmonized system, they are now called safety data sheets and have a uniform format that allows employees to obtain concise, relevant, and accurate information more easily. Your facility maintains a safety data sheet for every chemical in the workplace as part of its hazard communication program. You should review the SDS before working with any chemical or anytime you have concerns about safety issues. Always ask your supervisor if you have any questions about a chemical label or safety data sheet. And of course, always wear the proper protective equipment specified by the container label or safety data sheet. This often includes wearing gloves, protective clothing, and goggles with a face shield. Respiratory protection may also be required to avoid breathing in hazardous fumes. If you are unsure about the required PPE for any chemical, stop and ask your supervisor. In this program, we have discussed the company's written hazard communication program, as well as the hazard categories and classes of the global harmonizing system. We have also discussed the communication elements of the global harmonizing system, such as pictograms, signal words, hazard statements, and precautionary statements found on chemical labels. But we need to make one final and very important point. None of the information we have presented today will keep you safe unless you make a commitment to understanding and following safe work practices when using, handling, or storing hazardous chemicals. And your organization's hazard communication program is designed to provide you with the information needed to do just that. Now, go have a great day and a safe day.